Good afternoon, and welcome to our webinar on how to mitigate environmental and energy impacts of data centers. As plans for a massive wave of new data centers take shape across the US and the world, the rapid expansion is expected to carry a heavy environmental cost. Today, you will not only learn about what impacts are the worst for the environment, how to best address them, but also how data centers could be beneficial to communities and biodiversity given the proper planning. Today, we are joined with Cheryl Ginyard Jones, Managing Directors of Ramboll Americas, and Ansett, Ramboll's Global Director of Data Center Technology and Innovation, for a comprehensive look at the environmental challenges posed by data centers and the strategies being developed to reduce their impact. Next slide, please. The session will highlight key insights from our newly released white paper, which can be found in our news section of the website, followed by a question and answer session. To ask a question, please type it in the Q&A box. If we don't get to your question, please send me an email and I will follow up with a response. This webinar will be recorded and emailed to you after the session. With that, I'll pass it to Cheryl.
And hello, everyone. Thank you for joining. Ramboll is a global engineering, architecture, and consultancy company founded in Denmark in 1945 with a mission to create sustainable societies where people and nature flourish. We are an independent company with a conscience. Owned by the Ramboll Foundation, we choose principles over profit. We pursue meaningful projects that lift and empower businesses, schools, and communities towards a brighter, greener future. With over 19,000 experts collaborating across 35 countries, including over 2,000 locally here in the Americas, we deliver holistic, integrated solutions rooted in science. Here in the Americas, we have an extensive experience designing and building complex systems in water, power, architecture, and environment and health, along with management consulting services. With 80 years of history in the Nordics, Europe, and beyond, we bring cutting-edge technology and lessons learned from energy and policy transitions. We bypass potential pitfalls and offer one-stop, long-term sustainable solutions for our clients, including data centers. Our experts, such as Ed Ansett, joining us today, are some of the early pioneers of the mission-critical facilities industry. Our data centers teams have been designing, siting, and building data centers in the US and around the world since the dot-com boom in the 90s. Just last year, we were involved in over 220 data center projects in the US alone, with clients from the biggest international tech companies to boutique enterprise and co-location companies. Data centers pose a unique challenge because their impact is significant, whether from a technological AI perspective or an environmental one. We work with our data center clients to identify impacts, incorporate mitigation strategies at the siting and design phase with the goal of achieving net zero when possible. Without further ado, I'd like to pass it on to Ed to provide the full picture of the types of impacts we are seeing and what we recommend to address. Over to you, Ed.
Good afternoon, everyone. It's a pleasure to introduce Ramboll's Data Center Sustainability Roadmap. We'll just cover some high-level points because a lot of the details actually in the roadmap. There are 6 key areas that are addressed, and then, as you can see on the screen here. And for each of those areas, we've identified what we believe are achievable benchmarks in terms of carbon and environmental impact. So, we all know that data centers energy demand is growing at a huge rate. I believe it'll be about, in the data center demand will be about 3% of global energy consumption by 2028. So the reality is, unless we do something, data centers are contributing negatively to climate change. And really, this is what's prompted the roadmap. Next slide, please. So one component we'll obviously discuss carbon because that's usually a central theme when it comes to sustainability, but of course there's more to it than carbon. One component of carbon is what's called embodied carbon. And so essentially what this is the carbon associated with producing the materials that go into the data center, right from material extraction from the ground, mining, processing, transportation, assembly, and so on. That's called upfront carbon. And then another part of embodied carbon is in use, so things like fugitive emissions from refrigerants. And then finally, there's end-of-life embodied carbon, which is the disposal of the assets at the end of the day and decommissioning of the data center. And the key thing about the embodied carbon in the data center is that there is a disproportionate amount compared to, say, a comparable sized office building. Maybe several times, certainly 2 to 3 times that we would expect in an office building or a light industrial building. And then there's the mechanical and electrical plumbing services, the MEP services. And unlike in conventional buildings, you might expect in a data center, they are significant. In fact, the last study we did suggested they were about 60% of total embodied carbon. So next slide, please. There are lots of steps that can be taken to minimize embodied carbon. It's important that these steps are taken early on in the design process. So, but things that we can do is things such as excluding raised floors, prefabricating components to minimize waste, use of low carbon concrete and steel, and one of the best ones, but not always possible, is to actually reuse a building, because by reusing the building, we don't have to have new foundations. We can reuse a lot of the structure and so on. So those are some of the highlights. More details are obviously in the roadmap itself. Next slide, please. The other part of carbon is operational, and you can see from the graphic here how large data centers have become over the recent years, and we all know that's largely driven at the moment by AI workloads, which are around about 60% of total compute growth. The key with operational carbon, assuming the data center is using the utility for its power supply, is where it's located and what the generation source is. Okay, so if we've got a utility which is heavy on fossil fuels, the data center is inherently disadvantaged compared to one which is attached to renewable sources. Next slide, please. So, sort of things that we do to mitigate operational carbon: improve efficiency, obtain power where we can from renewable sources to the extent that it's available. As I mentioned, optimize locations with low grid emission factors. The Nordics, for example, are a good example of places where the grid emission factor is lower. The use of power purchase agreements are good, because although they don't directly reduce the amount of carbon in the grid, on the grid, they do encourage more renewables, and that in turn causes the grid fuel mix, the mix of generation, to improve from a carbon point of view. And then another way, but this is only applicable to end user data centers, control of the IT load and things that can be done, like enabling processor sleep states and consolidation, and even shifting IT workloads geographically to low carbon data center locations. So next, please. This is one area where data centers can be really proactive in terms of sustainability. Data centers have an inherent ability to participate in demand response. Now, demand response is where the data center provides the utility with services. So that might be energy export or grid stabilization and so on. Now, this is good not only from a point of view of making money for the data center owner, but it also can help reduce marginal carbon emissions. And other things we can do, we can export heat, especially now we've got more and more liquid cooled data centers as the GPUs have increased. We've moved more towards liquid cooling, and therefore the quality of heat that we get from a data center is often predisposed to things like heating homes, provided district heating, or agricultural uses and other types of off-takers. Next slide, please. Often overlooked is, in most locations, when a new data center is built, so most locations perhaps except deserts, we're going to disturb the biodiversity. We're going to remove plant life and animal life and disrupt the ecology in the location that the data center is built. So thought needs to be given to this. And the other thing is, if we move data centers close to urban areas, and we see this quite a lot now, this can also cause a problem called the urban heat island, because data centers eject tens of megawatts of heat, sometimes hundreds of megawatts of heat. So that can be very significant and needs to be addressed. And then there's the embodied ecological impact, which is a bit like embodied carbon, but it's not. It's more about the ecology. So this is about the supply chain, all the things that go into the data center, and the biodiversity or the loss of biodiversity associated with that supply chain process. Next slide, please. So with regard to biodiversity, one of the most important things to do is to get the ecologists involved early on to understand what the effects are going to be of building the data center, and how that can be mitigated in terms of strategic planting, reintroduction of native species, and the sighting of these species, and so on. The roadmap, as I mentioned before, identifies some achievable proposed benchmarks for the data center industry. And in terms of biodiversity, what we've gone with there is what is now law in England, which is a biodiversity net gain of 10%. It's not always achievable on site. If it's not achievable entirely, the full 10% on site, then offsetting biodiversity offsets have to be used. But anyway, that's one of the metrics. Next slide, please. The construction industry, like many industries, has for years used this take, make, dispose model. We're moving now towards a circular economy. I think pretty much everybody understands the importance of doing that. And the data centers industry is actually in a really good position to do this, because practically everything is in the data center. And I'm not talking about the IT things here. I'm talking about the building and what I call the MEP, the mechanical, electrical, plumbing, can be recycled. Next slide, please, Gautam. But the key to that is in design. So we need to design systems so that they can be disassembled, so that they can be taken apart, recycled, reused, and so on. This is all possible, and our intention is that what we should be doing, and we recommend others do as well, is include circularity passports in our design, so that our suppliers and the supply chain understand that we need to know the provenance, the carbon provenance, the environmental background of the products, both pre-construction, during use, and at end of life. Next slide, please. Water is obviously an issue, particularly in water-stressed areas, and there are quite a few data centers, large data centers, being built in water-stressed areas. In the US as well, there's been a tendency in the past to use evaporative cooling systems, are very heavy on water use. Now, we need to address this problem. The dilemma is, for data center owners and operators, historically, by using a water-based evaporative system, they save energy, they save electrical energy. So there's this trade-off between water use and electrical energy. The metrics we refer to are WUE, water usage effectiveness, which is a measure of how much water you use with regards to the IT equipment, and PUE, power usage effectiveness, which is a measure of the electricity use in the context of IT efficiency or load efficiency. So it's choosing the right cooling system is very important. Perhaps go to the next slide. So in terms of water, there needs, as I say, there needs to be a balance, a trade-off, a considered decision in the context of water stress or not in a particular area. And that will, to a large extent, or should, help us decide which is the best or most appropriate cooling solution. And then there are other measures which are, pretty positive, things like harvesting rainwater to the extent possible, using low-grade water, water recycling, and so on. The goal here, the proposed benchmark for water, is water neutrality. Next slide, please. Okay. Thank you.
All right, thanks, Ed. So before we get into the Q&A session, I just wanted to see if you can walk us through some steps of what it takes to build a net zero data center.
So if you recall at the beginning of that slide deck, we had those 6 key dependencies, sustainability dependencies. The reality is it's not just about carbon, it's about environmental issues as well. And there's water, circularity, biodiversity, all of these things. In our opinion, we need to look at getting as close as we possibly can, practically, to the proposed benchmarks in the roadmap. They may need some change, some modification based on specific sites and various nuances, but that's the first thing. And then in terms of carbon, well, we need, again, early on in the design stage, to think about embodied carbon, how we can minimize that. And an operational carbon, this is really important because most data centers are not in low grid emission factor utility environments. They're not in next to hydro or wind farms or whatever. So it's important we take the measures that we mentioned earlier. One is to export heat to whatever off-takers, and that means planning. That means that to do that, you've got to site a data center in a location where there is a heat off-taker. And then, of course, the demand response, which can help the grid and in turn help the country reduce its margin emissions. So I'd say those in a nutshell are the key sort of steps.
That's really good to know. What would you like reporters to take away from today's webinar?
I hope data centers have got a bad press, and I think rightly so. What I hope is that people can look at this roadmap and say, you know what, maybe they can do positive stuff. Maybe they can be good citizens. And this is some of the things we need to do to make that so, demonstrably so.
That's definitely a very important point. Now let's definitely move towards the question and answer session. If folks have a question, please feel free to go ahead and type it in the Q&A box. And if we don't get to your question in today's session, we can follow up via email. I'm going to start out with one of the few questions I've already received here. Which regions in the United States are leading the way in sustainable data centers, and which are lagging, and why?
So you probably guessed I'm from the UK. So I'm really not qualified to answer that. I'm sorry.
Okay, no, that's fine. What is the hardest part in building a net zero data center? And are there similar types of buildings or facilities that have similar impacts?
I think the hardest part is convincing whoever you're building for that there may well need to be some additional cost associated with achieving these sustainability suggestions. There are instances where that isn't the case, and that's great, and they're clearly, relatively straightforward things to do from a planning perspective. But it's where there's additional cost that sometimes we hit problems, because obviously corporations are usually consider bottom line as a priority. I think sustainability is high on their agenda, but there is sometimes a trade-off between profitability and sustainability. Not always, but sometimes.
So what would you say is the most expensive portion of building a data center to make it net zero? Like, what is the biggest investment?
I would suggest that's in the operational carbon side of things, where we need to be able to export heat. Well, that costs money. We've got an additional plant. It's not that expensive, but it needs to be done. We need to be able to participate in demand response. And again, we have to have systems that enable us to do that. And then, of course, there's the whole offsetting thing. And I didn't mention this earlier, actually, but, in terms of getting to net zero, from an operational carbon point of view, yes, we should do demand response. Yes, we should export heat. But ultimately, we do need carbon offsetting. And whether we like it or not, we suggest that is a last resort, that we don't do that first, because that's what has been done in the past, as many organizations have gone for offsetting as their primary approach. We think we should do the sort of proactive, more difficult things in terms of energy export first. And then when we do use offsetting, it needs to be verified because, as many of you know, offsetting has had a bit of a checkered history in terms of its credibility. So we need to use a verified carbon standard, or one of the accredited carbon offsetting schemes.
So this next question is very related to the one you just answered. How can data centers be more transparent in their sustainability activities?
Well, some of them are trying to do that in terms of the stuff that they report from a mandatory carbon reporting point of view. The transparency, if we want full transparency, we're going to need to ask for it. I say we, society, needs to say, look, guys, what's really going on here? I'm not sure all organizations will want to volunteer that information if perhaps they're not being as proactive as they could from a sustainability perspective.
Here, I guess this kind of also is related to the previous question. So, what is Europe and other areas outside the United States doing to lessen the impact of data centers?
Well, the EU is doing quite a bit with its energy efficiency directive. Germany, for example, has mandated as a legal requirement now that all data centers by 2028 need to be able to export 20% of the heat. That's mandated in law. As I mentioned, in the UK, it's mandated in law, or rather in England, I should say, there needs to be a biodiversity net gain of 10%. There's also more and more focus on circularity within the EU. So there's a lot going on. A lot of it isn't really just focused on data centers, but data centers are caught up in the legislation or the regulation. So I would say there's quite a lot going on there. I think also in Asia, Singapore's doing some good stuff. The Singapore government's doing some great stuff in terms of monitoring and regulating the sustainability potentials of data centers.
Nuclear energy is having a comeback in the United States. How do you think that will affect the environmental impacts?
So from a carbon perspective, nuclear is pretty good. Okay. I personally don't see data centers having their own SMRs. I see I should say small modular reactors. Okay, this is what we're talking about, sort of up to sort of 300 megawatt reactors. I think personally that I do see a future for SMRs just because of the burden placed on the utility grid. And so I think there's a certain inevitability about their success. But in terms of their application to data centers, I think data centers may well use SMRs, but there's, with data centers, they require redundancy. They require backup equipment. So you don't just we won't need one SMR, you'll need two. So I think my view is that SMRs we'll see more and more of them rolled out. I don't know that they're going to be attached to data centers, or if they do, the extent. I don't see a direct correlation there. I think a lot of people have looked at that and said, yeah, we'll have an SMR, without really understanding how long that's going to take to get the SMR, how much it's going to cost to get the SMR, how much things that need to be done, the shielding associated with SMRs, and the fact that you've got to pay for, basically the operating cost of the SMR up front in terms of fuel and so on. So I see a future simply because of the constraints on the grid, not just here, but many places. But I don't see them as really being dedicated to data centers. Maybe, but I can't see it at the moment.
Okay, great. We have one last question here. Nevada and the Southwest is a hotspot for data centers, even though there is record drought. What makes the desert area so attractive for building data centers?
As I understand it, and I'm no expert on this, obviously, as I mentioned, the US is not I don't live here, but my understanding is the cost of land is so cheap there. So, building in the desert and buying land in the desert, I believe, is considerably cheaper, but I'm not 100% certain of the answer to that.
Well, thank you, Ed, and thank you all that joined today's webinar. For more information, please go ahead to www.ramboll.com. And with that, enjoy your afternoon. Thank you all.
Thank you.